Good morning, friends. Myself, Chandra Kumar. I'm giving a lecture on electrical machine. Electrical machine is basically a combination of two words. One, electrical, another, machine. Electrical is associated with the motor which are associated with a electrical supply or deliver the electrical supply as an output. So input and output, if both are the electrical, then it is called the electrical associated machine or electromagnetic electrical machine. Electromechanical electric also called it is also called as a electromechanical energy conversion device, which will convert the electrical energy into the mechanical energy or mechanical energy into a electrical energy with a combination of in between of this one there is a magnetic field. Magnetic field is basically a medium in between the electrical to the mechanical or mechanical to the electrical. If we are saying that the electrical machine is there, so then the machine is a combination of two words. One is associated with the motor, another is associated with the generator. So if we are saying that it's a electrical motor, so it will be associated with the conversion from the electrical towards the mechanical conversion. So it will be called as a motor. So we give the input as an electrical, we are getting the output as a mechanical. But in case of the electrical generator, there is electric mechanical as an input and the electrical as an output. So mechanical to electrical conversion, also called the conversion parameter. So there is a conversion from the electrical to mechanical or mechanical to electrical. So it is called the electromagnetic mechanical movement or electromagnetic electrical conversion. Electromechanical energy conversion device. So it will convert the electrical to mechanical or mechanical to electrical. So there are lots of machines are there which are associated over here. I just used to share the lecture. I would like to share my screen with the with this one. You are finding that there is a world of electrical motor. So as many motors are there, same kind of electrical generators are there. So whatever motor is associated with it is also associated with the electrical generator. So DC motors having the brush DC motor and brushless DC motor. AC motors, there is an induction motor, synchronous motor and the linear motor. So brushless motor means a DC motor which having the different types of brushes are there. Then this is called the brush motor. There will the another variety is indicated as a brushless DC motor. Brushless DC motor means there is no brushes are there to convert the signal from the one side to the another one, right? Another one, there is a DC motor and the AC motor. AC motors are two or three types: induction motor, synchronous motor, and the linear motor. If we are seeing the motor is again there is a two parts. One part will be indicated as a stator side. Second part is indicated as a rotor side. The stator part always associated with a stationary parameter. So it will always stable and stationary on a floor or a position where we have to just stable it. And the rotor part is the rotating part which will be rotating in nature. So it will rotate a specific speed. So if we are saying that if there is a two parts, then automatically in a motor or in generator there is a two windings are associated over there. One winding which is associated with the stator is called the stator winding. The winding which are associated with the rotor, it is called the rotor winding. So whenever we are saying there is a DC motor, so there is a stator winding and the rotor winding. Similarly, in case of the AC motor, there will be again a stator winding or the rotor winding. Synchronous motor, there is a stator winding, rotor winding, but it will be quite different in case of your linear motor. Linear motor is the advanced version of all these DC motors or the AC motor. There is a, if it is associated with the induction motor, this is called the LIM. LIM means linear induction motor. LSM for the linear synchronous motor. All these machines which are associated over here, like a DC motors, induction motor, or the synchronous motor, they are the rotating machines. They are rotating in nature. But in case of the linear motors, there will be the rotor is there, there is a stator, but the advanced version of this one, so the rotor, the stator is not in the form of a circular, it will be in the form of a linear. As we are saying that there is an example of the fast moving motors, fast moving trains which are generated, which are associated with the uh, which are operating in Japan, like which are generated which are operating in Japan. So these are the motors which are associated with the high speed motors. They are all the linear motors. Now under this category, we have that normally we are discussing about these three motors. One is the DC motor. DC motors are the brushless DC motor or brush DC motor. Brush DC motors, as we know that there is a two types of winding: armature stator winding and the rotor winding. So if the stator winding and rotor winding both are connected in parallel with each other. So then it will call the shunt wound type DC motor. If both winding, the stator winding and the rotor winding, both are separately excited. So there is a two basic categories are there. One is the separately excited, another is the self-excited. If it's a separately excited means we are deliver the supply to the stator and the rotor independently. We are not associated with each other, that both are connected with the magnetic field. They are associated with each other. And if the both windings, stator winding and the rotor winding, both are combined together and we are deliver it by a single source of supply, we are using them. This called the self-excited. And under the self-excited, there is a different types of DC motor. So if the stator winding and the rotor winding both are connected in parallel with each other, then this type of motor is called the shunt wound motor. If the if the if the stator winding and the rotor winding both are connected in series with each other, supply is common and connected connection between them it will be in a series. So this is called the series wound motor. If both windings are there, means there is a series winding, there is a series winding, there is a shunt winding, and again there is a stator winding are there. If all three windings are there within the system, then this type of connection there is a compound motor. So compound wound is there, both three windings are there. So if there is a three windings, so automatically there is a multiple types of combinations are there. One, whenever the series winding and the stator winding both are connected in series and the shunt winding are connected in parallel with each other with this one, then this type of motor is called the lone shunt type motor. If the series winding and the shunt winding, if the series winding and the stator winding both are connected in parallel with shunt motor, then this is called the source shunt. So the automatically the application will be changed as per the requirement. So whatever be the requirement for a device, then the motor connections and their connection with the winding of the stator and the rotor winding are quite different from as per the application we are associated over there. So all these machines, whenever we are saying, they are all associated with the application. The which type of application is there? Accordingly, we have to just meet the combination within the machine, that what type of combination is applicable to operate this type of motor. Another category in the deep brush DC motor is the permanent magnet. Under the permanent magnet motor, we are finding that the permanent magnet are there in place of a rotor having a winding are associated. We are just making the permanent magnet. So we have the only the one supply winding are there, which will be excited by the external sources, and the rotor part is never excited by the external source. It will be permanent magnet type. So there is a permanent magnet is there. So there is no need of the external source we are given to the motor side. So it will be called as a singly excited motor, where the single excitation is there towards the stator side, and the rotor side there is no signal is associated. Similarly, there is a servo motor and a universal motor. These are the two advanced versions of the DC motor, usually associated over here as per the application. Servo motor is normally working to be the same as a stepper motor and the servo motor and the universal motor is not covered under this one. So we are not discussing, but they are also work as a DC motors, and their speed and the application are quite different from the as per the requirement for the customer. Next will be the AC motor. AC motors having the two main categories. One is the induction motor, synchronous motor, and the linear motor. Linear motor is the linear in motion is there. In the induction motor and the synchronous motor, there is a rotational motion is there. Whenever we are saying about the induction motor and the synchronous motor, then we are saying that again there is a two types of winding are there. One winding will be placed over the stator side, another winding is placed over the rotor side. If the stator winding is there and the rotor winding is there, if we are deliver the two supply, then it is called the synchronous motor. As we know that it will be AC under the category of a AC motor. So obviously synchronous motor having the stator visually excited with the help of the AC supply, but the rotor it will be excited by the DC supply. But in case of an induction motor, again there is a two types of winding, stator winding and the rotor winding, but we are only exciting the stator part, not the rotor part. If on a special cases, then there is an option that I can excite the rotor part, not exciting the stator part. So induction motor, it will be always a singly excited. So single excitation is there, means we are using a single source to excite or operate the motor. So if the single source is there, then it is called the induction motor. If it will be a doubly excited, then it is called the synchronous motor. Similarly, the DC motor is again a doubly excited motor, but doubly exciting and both excitation will be delivered as a DC supply. But in case of synchronous motor, it will be doubly excited. The stator is excited by the AC supply, and the rotor is excited by the DC supply. So it will be quite different from this one. So synchronous motor, one major application is that this synchronous motor is always run on a constant speed. Their speed is always constant in nature. It never varies. It will operate on a synchronous speed. So it is called the synchronous motor. Synchronous speed means the natural speed of the magnetic movement. There is a magnetic field. Magnetic field is rotating on a specific speed. That specific speed called the synchronous speed. If a motor is operating or running on a speed of synchronous speed, then this type of motor is called the synchronous motor. If it's a generator, then it's called the synchronous generator. If the motor is not operating on a constant speed, and the speed will vary as per the load will be changes, then this type of machine is called the induction motor, and it never run on a synchronous speed. So first we will start with the induction motor. Induction motor, again there is a two category. One is the squirrel cage, second one is the wound rod. Squirrel cage indicate as a cage. There is a wind, there is a state, there is a rotor having a different type of rotor are there. The rotor structure is defined as a cage. Means it will work as a jail over there, and all the windings are short circuited with each other. So there is a squirrel connection in between at the end of the both parts of the winding, because whenever we are saying that there is a two windings are one winding is there, so there is a one part is the starting end, another part is the ending part. So end, start and end, if start is short circuited with each other and the end, say ending part, it will be short circuited with each other, then it will form a case. Means all the winding are associated over here and they are form a case, or it will form a cylinder having a cage structure. So it is called the squirrel cage in nature, and it may be two types, three phase type or the single phase. Normally we have the two types of supply are available. One is the AC, one is the single phase supply, or another is the three phase supply in another category of the AC supply. Okay? So if we are saying there is a three phase, then there is a four types of designs are design A, design B, design C, design D. So whatever requirement we have to perform, as per the requirement of the customer, the design will be changed. So it will come under these four standard designs. Another one is the single phase. Single phase having the shaded pole motor. Split phase. Split phase having the different categories are capacitor start motor, capacitor run permanent split capacitor, capacitor start and run motor, and next one is the resistance start motor. So this type of motor we are already available in the market, and we are normally using all these motors. Steady pole motor we are using in the toys. The children's toys is associated with the steady pole motor. Split phase like as capacitor start motor. They are quite different applications, quite different from the another one. It will be require the capacitor at the start just to start the motor, and then we are disconnecting the capacitor from the supply, and motor is continue to run without requirement of any other sources over there. Capacitor run motor means whenever the capacitor is connected, it will be placed permanently within the motor, and it will be connected and operating to operate the motor. Then there is a capacitor start and run motor. Capacitor start and run motor means that there is two types of capacitors there. One is connected for the time being whenever the motor is just start, and after taking a specific speed, the start capacitor is disconnected and the run capacitor is under the processor. So there is a combination of two capacitors in such a manner that the motor will be at the start with having a higher capacitor value, and whenever the motor just get started, then there is only the single capacitors are there. Another method to start this type of square gauge induction motor is the resistance start. Over here we are just keeping a different combinations of different resistors are connected in series or in parallel, and make the operation of the motor that it will be start on a specific speed. Second category is the wound rotor. Wound rotor, again there is a three phase or the single phase. There is a three phase wound rotor. Wound rotor means, as in case of our squirrel case, there is a cage structure there. All the windings are short circuited with each other. There is a end range, one end range is there, another end range is there, and they are just connected with like that. But in case of the wound rotor, there is a structure of the rotor. It will be just like a cylinder, and the winding are interconnected with each other. In place of a short circuiting the winding with each other with the end, now the winding is not short circuited with each other. It will be connected in a particular manner so that the supply is distributed within the conductors, which will be associated with the rotor side. Stator having the normal winding structure as in the induction motor, as in the squirrel cage, but in the wound rotor type, the rotor structure is quite different from the squirrel cage. So this will be in the base of a three phase. In case of a single phase, there is a three types of structure: repulsion type, repulsion having the repulsion start motor and the repulsion induction. Similarly, there is a synchronous motor. Synchronous motor, again it's a AC motor. So there is a three phase supply or the single phase supply. For a three phase supply, there is a Again, four categories. One is the permanent magnet type. As we are knowing that there is a permanent magnet is associated with the DC motor. Similarly, there is a in a three-phase synchronous motor, there is a permanent magnet time. Permanent magnet time is PMSM type. Permanent magnet synchronous motor. Over there, the DC part means of our rotor part will be placed by a permanent magnet. In place of we are giving the excitation towards the rotor side, we are not giving the excitation to rotor, it will be permanent magnet. So there is no need to deliver the supply to the rotor side. We are only deliver the supply to the stator. So it will be a permanent magnet type. Another is the synchronous reluctance. Synchronous reluctance is a synchronous type motor which will be operating and give you the reluctance part, and the reluctance of the motor it will be changed. As the reluctance is changed, the automatically the motor speed will be varied. So this type of synchronous motor having this type of features, like initially we are saying the synchronous motor are operating on a constant speed, but under this one, the synchronous motor can vary their speed as per the requirement of the system. Another one is the hysteresis motor. Hysteresis motor is there. This motor is operating and give you the hysteresis losses. So over the hysteresis losses increases and the motor is applicable to give you the give you the satisfactory output as per the requirement of the load. Then there is a synchronous induction. Synchronous induction motor is basically a combination of the induction motor and the synchronous motor, where we have the some winding of the rotor are so circuited with each other. So at that moment, the combination of the squirrel cage and the combination of the synchronous motor, there is some part will be related with your squirrel cage type of induction motor. So this type of machine is called the synchronous induction motor. Under there is a second category is the single phase having the reluctance motor, sub-synchronous reluctance motor, hysteresis motor, stepper motor, permanent stepper motor having the three varieties are there: permanent magnet type, variable reluctance type, and the hybrid type. Then the last category is the linear induction motor, and the linear synchronous motor. Linear induction motor or linear synchronous motor is the example of the turbo motors. Turbo motors are operating on a speed of 300 kilometer per hour to 500 kilometer per hour. And so we are finding that Japan or China are working on this type of devices, and they are using to operate a motor which are operate which is whose speed is more than 300 to 500 kilometers per hour. So this type of application is associated with the linear induction motor. So this will be the lecture for the general lecture for the DC machine and the AC machines, how it will be operated, how it will be working. So now we are just ending all the lectures over here, and thank you.